Welcome people. In this video we are going to look at the question 6 for mathematics paper 2 for the year 2023, and this question involves vectors. So let's look at this question 6a. In the diagram, OA is equal to vector 2a, AB equals vector B, OC 3b. M is the midpoint of OB and OC is parallel to AB. So these are very important. You need to make sure that you understand what it means by the midpoint. So the midpoint is just the point that divides a line into two equal parts. Now let's look at the first question. Expressed in terms of A and slash OB. The first one, vector OB. So if we want to move from O to B, which route can we use? So we can use the vector for OA since we have the value, and from A we use AB. So you make sure that wherever you are using it, you need to have value. So we'll say OB is equal to OA plus AB. So what is the vector OA? Is 2A, and it is going to be positive since we are moving toward the arrow, plus the vector AB is just B. So this is the vector for OB, for the line OB. We have it. Then let's move on to CB. How can we move from C to B? So there are two ways in which we can solve this vector. We can move from CO plus OB, or if you want we can say CO plus OA plus AB. We'll still get the same answer. So CB is equal to, we'll say CO plus OB, since we have the vector OB. Now look at the 3b's. 3b is OC. Now if we move in this direction, it means we are moving against the arrow. So we need to introduce the negative to the vector. So the negative, it will be negative 3b plus CB, then plus 2a. So if we do math here, we are going to have negative 2b plus 2a. Then we bring the one with positive in front, 2a minus 2b as our final answer for this one. Okay, so now we move on to vector AC. So vector AC, we need to draw the line here since we are not given the line. So this is the vector that we want. So for us to find AC is equal to, we'll move from A to O plus OC. So in this one, we are moving against the arrow, so it's negative 2a. Then OC will be positive 3b. Then we bring the one with positive in front, so it's positive 3b minus 2a as our final answer. Then what of the vector CM? How can we find CM? So want to move from C to M, so we'll move from C to O plus OM. Now if you look at this one, CO is negative 3b. Now we don't have the vector OM, but we have the vector OB. Now if you remember, we are told M is the midpoint of OB. So this M divides OB into two equal parts. So what this means is that we want half of the vector OB. So we are going to introduce half times the vector OB. So negative 3b plus half. What was the vector OB? So the vector OB gave us 2a plus b. We can expand. So 1 over 2 times 2a will just give us a. since 2 and 2 will cancel, plus half times b, this will just give us c, half b. We can now group the like terms, negative 3b plus half b plus a over 1. So we can simplify this fraction. So how can we simplify this fraction? So we just see, we'll multiply 1 times 1, then this will multiply by this one. So 2 times negative 3b is negative 6b, 1 times b is just b, then 1 times, for you to find the lowest common denominator, you can just multiply 1 times 2 is 2 plus a, which is our final answer, is negative 5b over 2 plus a, which is a minus 5 over 2b as our final answer. Now we move on to a question that involves calculus. The equation of the curve is equal to y is equal to x raised to the power 3 minus 27x. Find the coordinates of the turning points of the curve. Since the power is 3, we are dealing with a cubic function. Now, cubic function may have 2 stationary points. Now, if we are able to find a point at a stationary point, that is the turning point. Let me see if I can give you a visual representation. So the visual representation, let's say we have a cubic function, a curve like this. So at this point is where we call the stationary point. At the stationary point is where we consider as also the turning point, because it's where the curve is turning. So we have 2 stationary points for a graph like this one, but I'm not saying always a cubic function has 2 stationary points. A cubic function may even have 1 stationary point, or maybe neither. So we have two stationary points for this graph here. So this is also another turning point. Now at this point, at the stationary point, the slope, which is the gradient, is equal to 0. Even here, the gradient is equal to 0. So how can we use the concept of calculus to find the coordinate of the turning point over a cubic function? So we are going to find the first derivative of the given equation, which is x raised to the power 3 minus 27x. So we are going to use the power rule, and we are going to differentiate y with respect to x. So let's begin. So it's dy divided by dx is equal to, how do we use the power rule? So the power rule is like, we need to bring down the power. So the 3 must be written in front of x. Then immediately after we have done this, we need to subtract 1 from the power. Minus, we have this 27. Now, whenever the power is not given, it means it is raised to the power 1. So we'll do the same. We are going to bring the 1 in front of x, or we can multiply 1 times 27. It's the same. Then after we bring down our 1, we need to subtract a 1 also. So it's dy divided by dx is equal to, so this will give us 3x squared minus, here we are going to have 27 times 1 is just 27. Then 1 minus 1, this will be x raised to the power 0. According to the indices, we know that any letter or number raised to the power 0 is equal to 1. So where there is x raised to the power 0, it is the same as there is 1, which is, if we simplify our question, this will be 27 times 1, which is the first derivative for this equation, will give us 3x squared minus 27. Now remember, this first derivative where there is dy over dx is same as we are finding the gradient. We put m, so m is equal to 3x squared minus 27. Now remember, at the turning point, we say the gradient is equal to 0. So where there is m here, we are going to substitute with 0. So this will be 0 is equal to 3x squared minus 27. Now, how can we solve for the value of x? So after you are done differentiating and you equate the differential equation to 0, remember to substitute m with 0. Then after that, you need to solve the given equation, which is our quadratic. Now, since we have only 2, we have 2, which is 3x squared minus 27. We are going to use the factorization method. So 0 is equal to 3 is common. We take out our 3. 3 into 3x squared will just give us x squared, minus 3 into 27 will just be 9. Now the inside here, 9 can be written as 3 squared. So here we can use difference of 2 squares. We can still factorize it. So we have 0 is equal to 3. Here we are going to write 2 pairs of brackets. X here, the other x here, plus minus 3, 3. Now we can say over 3 so that we get rid of this one. So we have x plus 3 is equal to 0. X minus 3 is equal to 0. Now if we take positive 3 to the right side, we get x is equal to negative 3. So the first value of x is negative 3. Then if we take this to this side, we get x is equal to positive 3. We have the two values of x. Now, what is the next thing that we are going to do here? So the next thing that we are going to do is we need to find the y coordinate for each x value. So whenever you are trying to find the y coordinate, you need to use the original equation before you differentiate that one. So that's what we are going to use here. So the original equation is y is equal to x raised to the power 3 minus 27x. So let's first begin by finding the value of y by using x is equal to negative 3. So that's what we are supposed to do is where there is x, we substitute with negative 3. So y is equal to, we have negative 3 raised to the power 3 minus 27 times negative 3. Whenever a number with a negative is raised to the power 3, then negative will not change. So it's the same as negative 3 times negative 3 times negative 3, which is negative 27. Here, negative times negative will give us positive. Now, 27 times 3 will give us 81. Then what is the difference between 81 and 27? So the first value is 54. So the first turning point is negative 3, 54. So that is our first value of that. Then we need to find the second one. So the second one, we are going to use this one, which is y is equal to x cubed minus 27x. This time, while there is x, we substitute with positive 3. So 3 squared is 27, minus 27 times 3 is 81. Then the difference between these two numbers is negative 54. So the other is 3, negative 54. So these are the two turning point that we have. So under this question, you just have to master the steps that are involved. The first one, find the first derivative, differentiate. The second one, equate the differentiated equation to 0. After that, solve for x. After you are done solving for x, use the values of x to find the values of y. From there, the question is done. Then if the question is not find the coordinates of the turning point, this is the same as find the stationary point. So the first stationary point is negative 3,54. Then this one 3, negative 54. The only thing is the one with the highest y value is known as a maximum. Then this one is known as a minimum. So this is what we can say for this video. Thanks for watching.